Okay, at this point you should be through number 12, and I want to make sure that you, if you could, don't worry about checking with me here because I kind of went through that first one with you, but I do want you to check your value after we get done with this part. Okay, so now it says to click on the slightly soluble tab. So let's go to the FET here. And what I'm going to do is click on slightly soluble salts. And we're going to pick the MercuryBromide, Mercury 2 bromide. And we're going to do the same thing we did before. Again, we've got the ions. And in this case, we've got a really small amount. But it's a 1 times 10 to the minus 16 liters of solution. All right, I'm going to put that in there. And you're going to see, in this case, we get to saturation pretty quick. How do I know? Let's look at our numbers. They're kind of fluctuating, but no matter how much I add, right, I'm going to add a whole bunch, these numbers are not changing, right? They're staying pretty much, I would say 14 to 15, something like that, in that value. So I've got these numbers here, and I've got my liters, and my solution is at equilibrium. All right, so let's go back to our packet. So the first thing we want to do is look at what equation we have here. Remember, we're going to put our solute first, always, because it's dissolving into its ions. I put 2 plus there, not plus 2Br minus. Right? My KSP expression is going to be products over reactants, but in this case, remember, this is a solid, so we're not going to include it. And there's a 2 there, so that's going to be our squared, just like we always do. Okay, the first thing we're going to do is find our KSP value. I think what I'm going to do is I'm going to put this paper here because I don't have a lot of room with my pen, and I'm going to do that. Okay, so remember, we're going to do a rice table. Not a rice table. We're going to find our equilibrium concentrations and just plug and chug, right? Because in this case, I've got the equilibrium concentrations of my ions, and that's settled down. We're going to call it around 14 and 31. So I'm going to go back here. My mercury 2 plus is equal to 14 ions, 6.02 times 10 to the 23rd ions is 1 mole, and I'm going to put all of that over 1.0 times 10 to the minus 16, because if you remember, that is the number that's right here in volume. When I plug all that in my calculator, I get 2.3 times 10 to the minus 7 molar. If I do the same thing for Br minus, I get 31 ions. In this case, it's not the same, is it, right? Ions is 1 mole, and divide all of that by 1.0 times 10 to the minus 16, and that's 5.1 times 10 to the minus 7 molar. All right, so I'm going to plug all of that into my equilibrium expression. So KSP is going to be equal to 2.3 times 10 to the minus 7 times 5.1 times 10 to the minus 7 squared, which is equal to 6.2 times 10 to the minus 20. All right, now that I've calculated that, I've got my equilibrium concentrations, I've got my KSP. Now I can calculate my molar solubility. Remember, that is X. That is the X that from our rice table. And so we're going to solve for that. So this one's going to be a little bit, I'm just kind of moving everything up so we can see the rice table. Okay, so I'm going to solve this. I have HBr2 going to H2 plus 2 Br minus. Right? Remember, this is not in the equilibrium expression, so I'm not going to worry about it, but these initial concentrations are 0. My change is X, isn't it? Well, first let's do our shift. Our shift, of course, is going to go in this direction. My change is going to be positive and positive. My change is X and X, and this is 1, and this is 2. Okay, so now my equilibrium concentrations are X and 2X. Now, what I'm going to do here is I'm going to plug this into my equilibrium expression, which is up here. So Br minus is 2X, and mercury is 1X. So I'm just going to plug those in back here. That's what we've always done, and set it equal to KSP, or to the K value. So this is going to be X times 2X what? Squared. All of this is squared because my value, right, is 2X. I'm going to put the whole thing in there, is equal to 6.2 times 10 to the minus 20. Okay, so this is going to be X times 4X squared is equal to 6.2 times 10 to the minus 20, which is 4X cubed is equal to 6.2 times 10 to the minus 20. Let's pull this up a little bit. And X is equal to 2.5 times 10 to the minus 7 molar. That is my molar solubility. So watch out for those cubes and all that. Make sure you know how to do that on your calculator, because you will have to do that for these. All right, so now you've got many examples to work on, and if you have any questions, just let me know.